Hey everybody, how you doing today? I hope your morning's gone well so far. Um, actually, I can't really complain too much except feeling a bit under the weather. I think it's just allergies, but my throat is really bothering me today, so hopefully my voice will make it for a couple hours. I think we'll be okay. Also, yeah, there's a pretty big storm coming over. Um, and probably it'll be here in about an hour or so, so I hope it won't be too loud. But let's go ahead and work on the terrain generation some more. Okay, so I think I was about to start on the positional gen system, and just a little recap from yesterday. I'm trying to update the terrain generation system to work with Unity's new multi-threading and entity component systems. So we're trying to do an entity component type design, and just a short summary of that is that you try to encapsulate all data in little entity objects, and they can have separate components. Like, for instance, we'd have a section entity, and they'll have these separate components. And the components contain data, and then there's separate systems that contain logic. And so entities should never contain logic, and systems should never contain data is basically kind of a rule for this type of, I guess, programming structure. So one cool thing about this is that before we could really only break up this algorithm between the collision mesh and the graphics mesh creators. But now we can break it up even farther because, sorry, something in my eye. Each of these systems just runs on data and then deposits more data in here, and then another system can take up the reins. And then, of course, I want to try and make it so that each section can calculate as much information as it can without relying on any other terrain sections. That way we can run these in parallel. Of course, the biggest problem is the normals, because the normals depend on all their neighbor points, which means that they depend on neighboring sections and even neighboring chunks. So the normal generator has to wait until all the positions for every point has been generated. So that's kind of a bottleneck. But luckily, it's pretty much just at the end, and the only thing that happens afterwards are the mesh generators themselves. Okay, so let me see. Position. Okay, so we have I finished up the section generator and the layout generator. And what they do mostly... okay, I've got too many files open here. Yeah, so this basically, for every section, it figures out how many points are in there and then some information about how to arrange the points. And then I think the section generation system actually, yeah, figured out how many hexagon faces and margins that we'll need to create. And then when we actually get a real component system, which unfortunately we don't have implemented yet, we'd actually create a new entity here for a section. But we really just, for now, we just add it onto a list. Alright, so do I... yeah, I need to implement this. I think I'll copy a lot of this code. Okay, so this needs to be positions. Oh, one thing, okay, I need to do here is also make sure that our dependencies are complete. So it should also be section dot layout is complete. So if the layout's complete, then the sections. Then yeah, if the layout is complete, then we can start running positions. Okay, so here we're gonna try and find the position. So it's going to be a lot like we're gonna need to get this code, like to get the distort amount and the bump size, because we're gonna figure out all of that. Except we won't deal with normals at this point, which I think I already. Yeah, I took that code out of here, so. Alright, and so it's gonna complain. Oh yeah, I just need to use Unity engine. It looks like one too many curly braces there. Okay, so really all we have to return here is vector 3. Or wait. I think that the position also figures out the blends just because they're related. So, okay, well no, it does do some math on the blend, so we'll wanna, I guess, just have, or we could just pass this section and then this make new point can just place this data into the point instead of returning something. Okay, so let's change this to set point, and then we'll also just pass in maybe first, and then the end point. And it won't return anything. So section blends point equals blend, and then the section position is center. Okay, so I'll need to update these other versions. Cannot use local variable point before it's declared, but it's an argument. Oh, okay. I think this variable here is confusing it. Oops, I didn't want to delete that. So section dot blends point, and then here's the section dot positions. Okay, so now I just gotta update the last one, which is blending between 3 prototypes. Which I guess I technically don't need to update these right now because I'm actually only considering hexagon face sections for now, but we might as well do it while we're here. Yeah, so it's no S there. Right, oh yeah, no return. Why is that on an else if? I guess I just left it out by accident. Okay, and then this should be semicolon. Probably need to do the same thing here. This is another error, but I don't see it. Oh. Okay, there was, I don't know, I think that the indentation was just messed up. Okay, and yeah, this blueprint cell doesn't exist anymore, so I'm not sure if we'll need this function. Okay, so the only other thing is I want to change the name of this to set point and this to set point. Okay, so I think we're good to go. I don't think I'll need this function anymore. I don't even know if I use a triangle average. I guess it's useful there. Although here I just calculate myself. Oh, that's because I already have the... I gotta form a vector of it, not just average between a few, so... Okay, so now we're ready to start creating the positions, and I could reuse code from here. Yeah, because I have this create hex face. I guess I could, but I was just wondering, like, is maybe an easier way would actually be, instead of thinking of it by fans, if I just created this whole hexagon and then, well, I guess it doesn't matter because I still think of this part as like part of a fan, so it's pretty much equivalent. And then I gotta make sure that I don't duplicate points. So I guess we'll just create this section for each side. I think that's what I did here, so maybe I'll keep this. Alright, so let's clean this up. So we gotta create the hexagon face. I don't need to do that at all. So the number of point rings we actually get from the section layout. Okay, I guess I should just pass the section. Okay, so I think it's the... Oh yeah, point arrange data is 0. I should probably refer... I think I kept it here. Yeah, the number of point rows and then the points on row 1 up to n. Okay, so I don't need to know the number of points because that's... Oh, do I actually use that anywhere? I just use it to create the arrays, so I guess I will, but that's also just given here. Okay, so now I need to create the position arrays and the blend arrays, 'cause that's what we'll be dealing with. All right, that doesn't exist anymore. Okay, so I do need to know the surface prototype, so I wonder maybe here we should just also have the surface layer, which would be given in this layout section. I mean, we could figure that out ourselves again, but I'm trying not to duplicate too much logic. Okay, so look, prototype. Oh yeah, so we've got to convert that to like world space again. I think that's what this helper class does. Where is it? Chunk section to world. Maybe I should just have another thing in here that just returns the prototype. And then the layer. And so I'll need the board, and then I'll just need to pass the game data because we'll also have to look up the prototype. Oh yeah. Get proto. And so first we'll have to get calculate. I guess we can. Let's do calculate position actually. Okay, so now we have that, and I can make a hex position. Given the column, the row, and then the layer. And then I want to convert that to an index. Okay, let's see. If hex position is valid on board, then we'll go farther. If not, we'll actually just return null here. Okay, and then we can just, well, I guess we'll need to get the proto ID. Actually, I'll need the proto ID because that's... Oh, wait. Now that I think about it, well, we still need to know the surface layer for the altitude, I think, but the prototype, I mean, the terrain index is given in the terrain vector, but then we'd have to convert from a float to an integer. I guess that's fine, but that, yeah, because that would be quicker than this. Okay, so that's just mathf. Let's round to integer. Section dot terrain 0. Oh yeah, and then we've got a database, block prototypes. Oh wait, no, the terrain is not the block prototype index. It's actually the texture index. I should probably make sure that I did that correctly, actually. Yeah, I actually don't. I just do the prototype index. So this needs to be changed to database block prototypes proto index dot texture index. Okay, and then let's just put the surface layer here while I'm here. Okay, yeah, so this won't work, so I will have to go back to this function. Alright, so the proto ID is just the board dot map board index, and then we can return database block prototypes. Okay, so chunk section to world get prototype. Okay, didn't help me out there. And the database, I think that's good to go. Alright, and so we can just pass that. So we're trying to make the center position here. We don't have to assign it to anything, we just call set point. The center point, oh yeah, because before this used to actually calculate the position. That's a good point. So now this flat position, we need to calculate within these functions. Or no, I think we should still just pass it. Okay, so now I need to calculate the flat position myself here. I'll just for the sake of getting these errors complete, I'll just pass 0 for now. So then we pass section and 0 for the first point. Okay, I should probably have a layout or document the way I'm going to position these points in the array. So let's see. Okay, so the point normals and blends. laid out in the array in this manner. Okay, so for a hex base, it'd be the center, and then okay, I'm trying to figure out the easiest way to type this out. So 0 would be the center. And then each point, so basically we want to, I'm trying to, should I just use this diagram as the specifications? I don't know, that seems like a bad idea. But I don't know, it's difficult to put this into words. So I guess we just go around each point ring from the north corner and then go in clockwise. For each point ring, start with north corner and proceed clockwise. Okay, I guess that's not too bad. Okay, so this is going to create the points. Oh yeah, that's a different type of class now. Maybe we should just pass the prototype through so that we won't have to do this calculation again. Okay, that looks good. So now let's figure out. Yeah, see, before these corner points were calculated for us in the blueprint generator, but now we've got to do it within this function. Let's just take a peek and see how I did that. Okay, center point. Oh, so I just says the hex math 2 world. Okay, that's pretty simple. Okay, so I don't actually have the hex position here. Alright, well this is a bit awkward. So calculate hex position. And we just need this information again. And yeah, we basically just return that. Oh right, we've got the layer. Okay, and so now I can just call calculate hex position. Okay, why is it not like that? It's public and static. Oh, that's calculate. There you go. So I don't know if I'll actually use this function now. I guess it doesn't matter. It's not like that's a very in-depth math. Okay, so hex position. Calculate hex position, section, chunk, section, hex index, and then the surface layer, battle board, and pass the metrics. Okay, so I could leave this here, or I could just get the prototype myself. Because it's not that difficult. So we want to board index, and I just pass the board here. The only thing different is that we don't check to make sure that this hexagon is in bounds, but I don't think we need to at this point. Okay, so hex position. That's all we have to do here. We've got to get the corners, but I think you just add that to the center. Let me see. Yeah, this is the center plus get corner direction, then you just multiply it with the hex radius. Okay, so I guess I better pass the center position as well. The flat center position is this. Of course, it's going to get distorted and have the bump map applied when we call the set point. So that's why we can't use what's in the array. Okay, so flat center position, and then we'll pass the surface proto. All right. So here's the last string. You can just use the number of point rings -1 to check that. But I don't know, why do I need that? Oh yeah, because we were testing normals. Yeah, so I don't need that anymore because this class doesn't even do normals. Okay, don't need to get the cell because that doesn't exist. The start index. Okay, so what this is doing. I guess I could have just added the corner index to start index at the beginning. Don't really need to be separate, I don't think. But yeah, the first index in any ring is the total number of points in the hexagon with 1 minus rings than what we're at. I think instead of doing this, I might just like accumulate the start index. There's a better way to do this, but it's not going to be that time consuming, I don't think. So calculate start index for ring. I'll need to pass this section too. And what I'll do is I'll just loop through the different, because we have the ring sizes in the point arrange data. So for int I equals 1, and it starts at array index 1. I think I'll actually do it this way though. then I less than point ring. So if we're on the first ring, then we only want to count, yeah, the one before, which would be the 1.0th ring, which is the center. Okay, so total plus equals section point arrange data I plus 1. Okay, offset by 1 since ring sizes start at index 1. Actually, it's not like, yeah, since the total number in that specific ring, it's not like the total number in all previous rings, so okay. Yeah, and I gotta pass this section. And there's no reason really to have corner offset as a separate variable, but I guess it does make it slightly more obvious what's going on. Okay, so this near lerp value is kind of confusing because there's no far lerp value, but really it's just the distance from the center to the edge of the ring, so I'm trying to decide what to call it. I guess radial lerp, maybe? Gosh, I'm way overexposed now. Okay, alright, so this is just lerping through, or cycling to find the next corner. So what I need to do, let's have another function just to get the position of a corner. So calculate corner position. And we'll just pass the center position and then the corner, and I think that's all I'll need. So that's pretty simple. Okay, so we can just pass calculate corner position and corner A. And then yeah, I need to also change this. Alright, so this is just finding the two corners here and here. So first we find, well, we know the center point, and then we find this position, and then we just take the lerp value between them. That's what that radial lerp is. Alright, and then... okay, yeah, and then we lerp between the corners here. Okay, and so next we'll just call set point section, and the index is start index plus p. And then the flat position is this position lerp, surface prototype, and the blend. Okay, yeah, and since every point on the hex face is entirely just the surface prototype, it'll always just be 1, 0, 0. So that's simple. Okay, and a lot of these functions we don't need right now because I'm only dealing with the hex face, but we'll need them later when we add in the margins because it's going to need to blend between prototypes and everything. Okay, so I think we're good to go. Oh, I need to call this run, so we'll just switch the section type. Okay, and we won't support anything else for now. Okay, num points on edge is assigned but not used. Okay, I guess we don't need that. Alright, I guess let's go ahead and test it. I think I need to create this position system first. Oh yeah, it's not the right interface, I don't think. So terrain mesh builder. Okay, got a null reference. Let's see what that's about. Distort map. That's interesting, because that means that this prototype doesn't have a distort map, which would make me think this is the... Or maybe the prototype is null. Well, that couldn't happen, could it? No. The prototype definitely couldn't be null, but... Okay, let's go ahead and print out some stuff here. So debug, log... string, format, chunk, x, position, then the prototype. Oh, this should be a curly brace. Okay, so section chunk, section hex index, and then we'll pass the hex position and the surface prototype dot name. Alright, let's see what that comes up with. Okay, so the empty prototype. Chunk 0, position 0. That doesn't make any sense. Okay, well it says the surface layer is 0. That's right, because there's dirt on the very first position. Yeah, so this would be at 1, 1, so the prototype should be... It's odd, so that means that it should be dirt. Okay, so it created the array correctly. So I guess What could be going wrong? Surface layer is 0. Okay, this one hasn't run yet. And I think the hex position, yeah, 0, 0, 0. Guess, can I actually see the data here? Yeah, so this is the index we should be getting. Because 0, 0, 0 should give me 0, which would be number 1. And if we look at the game data, the block prototypes, yeah, 0 is empty, which is what we're getting right now, but start is number 1. Alright, so I guess this toBoard index is not working, but that doesn't make much sense to me. Oh, yeah, I made a silly mistake. So this gives me the board index, but I've got to get the prototype index for this space on the board. So this is actually the board index, and then I've got to do battle board map. Yeah, I skipped a step. Okay. Okay, so now it seems like all that is working fine. At least it didn't crash. Okay, so, and we should look. Yeah, and here it does go up in elevation as we expected. I don't see any problems. I mean, yeah, it's gonna be hard to debug these positions, but I mean, I guess it looks fine. I don't see anything really out of position. Except this one is... Oh, well, that's basically 0. You can see the E at the very end. I was gonna say that 6 units is kind of big, but it's actually... I can't read the entire number. Oh yeah, it's basically 0. Alright. I think we're good to go. So let's just do the triangles real quick, and then I'll do the graphics mesh so we can actually get something back on the screen. And we'll just skip normals for now because, again, normals are just difficult to deal with. So this will be the triangle gen system. And the cool thing about this is that it can run simultaneously with the position generation. Let's copy some of this code. Oh yeah, I gotta rename the constructor. Okay, so this should change to triangles. And again, I did a little bit of this. Where was it? At the point, this is the old one. I don't think I did triangles here. But the old graphics mesh generator had triangle code for hex faces. Yeah, right here, and I think I had already updated it. Okay, so this try point. Oh yeah, we don't need that anymore. But I'll have to pass this section. And the cell index, I guess it's not needed. It's just a corner. But the triangles, we'll have to pass the ring index, of course. Okay, and it'll be about the same. I guess I'll go ahead and generate this add triangle, although I don't have to deal with the terrain right now. Okay, this should be int. And we're just going to return the index of the point in the local section point array. The graphics mesh can go and figure out how to offset these so that they're actually for the entire chunk. It's not really that difficult. Now, I don't know. I guess we could count. I was going to say, to initialize a triangle array, we need to figure out how, or its size. I think it'd be a lot easier if I either use, yeah, because the order of the triangles in the list doesn't make any difference. So it'd be a lot easier if I use a list and just add things on and then turn it into an array at the end. I think that's what I'll do. So triangle builder. And then after running it, we'll just clear the triangle builder. I guess here I could go ahead and do section triangles equals triangle builder to array. Okay, and so now I'll just add these. Okay, so let's you just need to update some of this information. So the number of points in the near and the far fan. I'm trying to figure out what these mean. Okay, yeah, we have to have a bunch of information because it had to like cycle between. I think so. What's this doing? Far point. Okay, and I can just pass the actual index. I don't have to do our index in the array for this. And yeah, no terrain. Just trying to figure out what, if I still need to do all this logic. Okay, number of points in the near ring we can get easier with just this section. Okay, yeah, because the way the points are laid out, we have to cycle around and stuff. I remember now. So this would be section, arrange data, and then the triangle ring. If we're on ring 0, then we want the first point ring. And then for the far one, we just do 2 plus triangle ring. And the start index, we gotta just loop through these again. I think it's kind of sad to copy this, but I mean this logic is pretty simple, so. And actually I'll just make this an out variable. So it won't actually return anything because we're gonna need both the outer and inner number of points. So near start. Okay, this will be the triangle ring. So the difference, like, this is point ring 0, this is triangle ring 0, point ring 1, triangle ring 1. So the point ring is the same, or the near point ring is the same as the triangle ring, and then the far point ring is triangle ring plus 1. Okay, so yeah, near start equals total. And then far start is total plus, we just go one more. Oh yeah, I needed to put the variables before this. Okay, and then the start offset is just the corner. Oh yeah, and so it's just multiplying it by 6. I could probably calculate this a little easier if I just use this and then divided it by 6. Although that wouldn't work if it's 1. Okay, so I'll just leave it. Okay, maybe we don't need the terrain anymore. Okay, so hopefully I didn't mess up the math here. It's going to be difficult to test these triangles until I get the mesh builder up and running because, and you can look at an array of triangle indexes and it's not really going to tell you much. Okay, and the last thing I need to do is just loop through this, so int corner equals 0, corner less than 6, and corner plus plus, and then we just create hex fan. Okay, so there we go. I think that's it for this. I might as well at least run the game with the triangle system and just make sure that there's no, like, I don't know, null references. Oh, should be systems. Let's go ahead and test it out. Again, we can look at the triangle array, but I don't think it's going to be hard to tell if the data is correct. But hopefully, well, that seems like we didn't get any null references, so that's good. I guess we can count the triangles and see if it matches up. So this, I can't see. There we go. So that means we have 18 triangles. And well, there should actually just be 6. Or wait, I did that wrong. So it's 18 divided by 3 is 6, isn't it? Yeah. So, okay, that is correct. And looking at the indexes, I can actually do make sense, because if we look here, this is 0.012, so let's pull this out. So I think we can test it here. So 0, 1, 2, and then 0, 2, 3. Oh, why'd you do that? 0, 3, 4, 0, 4, 5, 0, 5, 6, and 0, 6, 1. So actually that should work. And I think every hex base has the same triangles. That's interesting to see if we could maybe try to optimize this, because I think every section of the same type will have the same triangle layout. Like the triangles could even maybe be like pre-made, and then we just select an array based on what type it is. That's interesting to think about. I probably won't do it right now, but seems each section type has the same triangle array. Could either share array, or wait, share arrays and even have them pre-created for type. That's interesting to think about. Alright, so now I just need to make the graphics mesh builder. Okay, so this will just be visible mesh gen system. Just copy those. This one's a little different because it runs per chunk instead of per section. I don't need to do that, I just need to give it the right namespace. We will need lists, I think. So I guess I'll leave that there. Okay, so this one, well, I guess we're going to need to see if every section has its triangles and points complete before we move on. I'll have to change this because later it's going to have to wait for the normals to be complete as well, but... Okay, so bool all complete is true. Okay, so if triangles are complete and positions complete. I also, before I even do this, I should check to see if chunk.s visual mesh is waiting. Okay, and we need to invert this because if either is not complete, we need to set all complete to false and we can break out of the loop. Okay, and if all complete, then we run on the chunk actually. And then I need to set the visual mesh as complete. Okay, and now this doesn't care about the section type because again it doesn't run on sections. All it does is compile everything about the sections into a bunch of arrays so that we can deposit it into the mesh. And I already did some of that, I think. It'll be a little different, but... So I think I can deposit the vertices, the blends. Well, I gotta convert the blends to a color. Oh, well, no, because these are per section. Okay, I don't think I can actually use much of that logic. So we'll need a bunch of arrays instead of building instead of creating them every time. Let's try to be a little bit smarter. So this will be the vertex builder. And then vector 3, normal builder. Okay, I guess triangles will come next. And then a color. And last but not least, we'll have a vector 3 for the terrain. Okay, I don't need to create all these. All right. Okay, so now we're ready to deal with this. I guess I'll go ahead and do the end last, or end first. So we'll just need to clear all these arrays once we're done. Okay, so I don't know if we can... Okay, let's see if it'll let me do this. If not, we can just use the array. I seem to remember that it complains if the vertices don't match. But maybe if you clear it first, it will work fine. So set normals. Set triangles. Then what's it complaining about? Really? It won't just let me give a list like all the other versions? Okay, it's talking about sub meshes. Okay, well I guess we don't have a sub mesh, so it'd just be triangle builder 0. And yeah, we need to do the colors. Okay, this is blend builder. And And so now we just gotta set the UVs, and I think I put the terrains into the first UV slot. Let me make sure, because that actually caused an issue before. Okay, it's slot 1. I think slot 0 is reserved, so it won't let you set any like custom data in here because the mesh's own UVs will override it. Actually, this mesh has 0 UVs, but I don't know. I think I did it the other way before and it didn't work, but it's not that important. Okay, so now we've got to add everything into this. So we've got to loop through every section. Okay, so really the only thing that we have to deal with is we've got to keep track of the vertex when we start adding in the triangles. I guess that's pretty simple actually, because we can just read this vertex builder before we start inserting any vertexes, and that would give us the triangle offset. So let's say add section. Okay, so int try offset is just the number of vertices before we add anything to the section. Okay, and for int I equals 0, I less than section number of points. Alright, and then I gotta increment that. Okay, yeah, this will work fine. So vertex builder, add section positions. Oh, wrong array. And then we would add the normals here, except there's no normals yet. So I'll just add I'll just say vector 3 up. And the blend builder, we need to convert the array into a color. So new color section blends. Is there an easy way to do that? I think maybe you can like manually cast a vector 3 into a color. I don't know. Does that work? No. Okay, so blend to color, and then we'll just pass a vector 3. Oh, that's supposed to be a brace or a bracket. Okay, and new. Oh, I guess we gotta return this. So blend X, blend Y, blend Z, and alpha will just be 1. It doesn't really make any difference. Okay, and then the terrain is also on a per vertex array, even though it's the same for everything in this section. Okay, and so that's good. Now I just gotta do the triangles. Section triangles. Length. Okay, and the only thing we have to do that's different here from everything else is we've got to add on that triangle offset. So, yeah, because right now the triangle indexes are in section space. So, 0 would refer to the first vertex in this array. But now when we add everything to this list for the entire chunk space, we also have to add this offset. And I think that's it. So where does it deposit the mesh? I guess in the chunk? Do I have that? Oh, I call it the graphics mesh. I guess I'll rename it to visual mesh to stay consistent. I could maybe reuse the mesh if it already exists. So if, okay, let's do it this way. Equals chunk dot visual mesh. Then if m equals null, we'll just create a new one. And then m clear. All right. So now here I just gotta add this new mesh builder. Systems, add new visual mesh generation system. Actually, this doesn't need the database or the battle. So I'll just delete that. Okay, I think that's it. I guess it will know it is done when the visual meshes are all complete. So let's just try it and see if nothing else is broken. I know there's not going to be any like mouse picking because I don't do the collider mesh yet. Okay, the triangle doesn't need the board state either, apparently. Okay, we'll delete it for now. Not that difficult to add back in if it needs it later. The light keeps changing. Keeps getting cloudy and not cloudy. I'm surprised it hasn't started raining yet, to be honest. All the avatars are clumped over in that area. Okay, so yeah, now we've got some terrain. Finally. And I think it looks good. Yeah, it's still getting bump mapped, and I think it's distorted. Yeah, they're not perfect hexagons. So let's try to add in some more subdivisions and make sure that that works. And then we can start adding back start adding the margins back in. Let's start with one. It seems like I just tested this, but we keep on changing the system. This system should be final though because it's really modular, so. Okay, no issues here. So let's add one more. Or I might go crazy and do like 8 or something after this. I didn't leave any debug. Okay, no. So no problems yet. Yeah, 2 is like, I can't really see going any more than that normally, but I want to just test the upper bounds. Probably should put an upper bound in the actual game so that mods don't try to spawn with like 100 subdivisions and crash. Yeah, this is starting to take a long time. So let's see, with 8... Oh, okay, it actually crashed the UI. I think that the rest of the game didn't seem to have a problem, but there's 271 per chunk. Yeah, I think Unity might be crashed now. Okay. Not really crashed, it's just frozen. Okay, let me restart this, I'll be right back. It's actually still trying to do a bunch of work, but I'm too lazy to wait on it. Okay, yeah, so 8 was too many. Let's just go to 3. It'd be fun to try and test that later and see how fast we can get the terrain to work. But yeah, while we have this debug active, we can't go too crazy because it's just too much for Unity's UI system. Hey, X-Squirt. Yeah, I did break it. It's good to see you. Haven't seen you in a bit. Alright, so this looks good. I don't see any issues. Alright, so now let's try to join those hexagons together. Alright, so where do we want to start? I guess we've got to start at the beginning with the positions. Alright, now the layout. Because right now we just do hexagon faces. I don't think, well, the rectangular margin will actually be simpler than the hexagon because the hexagon has the ring thing, which makes everything more complicated. Okay, so a rectangular margin, run for rect margin. Let's move this down here. Let me see. What information do I want to store? Yeah, the number of rows, number of points on a standard row, and then... Okay, yeah, because we have a standard row and then the offset row. And the offset rows are just the odd numbered ones. And they just have 1 extra point, so there's no reason to really store that in the array, I don't think. Okay, so let's see, number of point rows, and then a size of even rows. I think that's all I'll have to put in here. So that makes this pretty simple. Okay. Okay, so the number of points is the same as the outer edge of a hex face. Which is just 6. Oh wait, let's see. So if there's 0 subdivision, then there's 2 on the outer edge. So that would be just the number of subdivisions plus 2. So number of points on even line, I guess. And what did I call it in here actually? Oh, I called it a row. That makes more sense. Okay, and then the number of rows total is just so I have the margin rect subdivision. So if there's 0 subdivisions, then we have 3 rows. So we just add 2 for every subdivision. All right, and I think that's... Oh, we got to figure out the number of points. Okay, so number of points on an odd row is just, again, the number of points on an even row plus 1, because we just offset it by half, then add 1 at the beginning. Alright, so I think that's good enough to figure out the total number of points. Let's see. So the number of even rows is equal to the number of subdivisions plus 2, and then the number of odd rows is just the number of even rows minus 1. I know a lot of these variables could be defined from each other, but I'm just writing it out to make it explicit. Alright, and then the section dot point arrange data. Okay, so I think I said the number of total rows and then the size of an even row. So that would be plus number odd rows and then number of points on an even row. Alright, and I forgot the brackets right there to tell the system that it's an array. What's it not like about that? Probably misspelled it. Oh, I forgot the on. So, is that all I have to do? Oh, I also have got to give it the surface layer and the terrain, which are kind of connected. Although this is, okay, for the margin I have to know the originating hexagon and then also the neighbor hexagon. Okay, so let me see. If we look at our diagram here, I have the neighbor offset. So I think, yeah, it's just this corner. Or the side. How did I figure that out? if I look down here, so I don't want the corner B. Okay, the neighbor cell. Oh, it's pre-calculated. That must be in here. Okay, so it's just, we just check to make sure that okay, let's make sure that the cell actually exists, because before we created dummy cells for neighbors that were off the board. And then you just, okay, so I thought we have this axis vector. And then we convert it to an index, alright. I don't need to copy it. Where was I? The layout. Let's have a function to return the neighbor. I think the only time we'll ever really care about the neighbor is when we need to get its prototype, but so get neighbor hexagon, and then I guess we'll just give our section and then the side that we care about. First we need our own hexagon, so alright, what did I call that? The chunk section of world. Calculate hex position, and then I give my chunk index and all this information. We don't care about the layer right now. That's a good point though, because we will need the prototype of the next surface layer, so we might have to, I guess we'll just have to call this get surface altitude for a different, for the neighbor. I might actually just pass the hex position in here. It doesn't make much difference really. Anyway. Typo and database metrics. Okay, so now we have, well, the neighbor is just my hexagon plus the hex position. What do I call it? Offsets. Oh yeah, axis vector. All right, and since we're working with hexagons, well, I guess I can actually show. It's not as easy as just moving one up or left or right. For example, here we actually changed two values at once. Okay, so hex position, neighbor. Let's get neighbor hexagon. Okay, the side would actually be in the section.side. I want to keep these separate in case we have to get a hexagon for a different side, which we'd have to do for the triangle margins, so. Okay, and so I need to get the prototype for that terrain and this altitude. So I've got to do all this. What does the surface altitude mean for the margin? That's a good point. Maybe it's a better idea to not pre-calculate this. Alright, so I'm going to need to go and update some other logic to deal with that. Maybe I should just have a separate vector 3 that gives like the... Oh, well no. Because I was going to say another vector 3 that gives the actual prototype indexes for each terrain. But the problem with that is we'd still need to get the surface layer from that. So I could give like the hex positions for each neighbor here. Maybe that's the thing to do. And then the mesh generator could just convert this terrain to each what am I trying to say? Convert the block index to the texture index. If I do that, then I should rename this. Probably I should have a different class. Figure that out. Okay, so this will just be vector 3. Or I could just do 3 integers. Okay, so I guess board index and then board index neighbor A. Because at most a section will only ever care about 3. Because yeah, I can only blend between 3 at the most, so that's going to be okay, I think. So here, I've got to calculate this terrain myself. It's simple enough that I think I don't need to have a separate system to do it. Okay, so vector 3, get terrain, and my index, neighbor, A index. Okay, and so for each of these I just need to, I guess I'll have another function that will return the texture index. Okay, so now I actually do need both the battle and the game database, which I just deleted those a second ago. Okay, and so for here I can just return database, block, prototypes, battle. Oop. Pressed enter too soon. Oh yeah, it's battle.board. Board index. Okay, so again we take the index and that gives us the... Oh, what's wrong with this? Oh, and then I need to take the texture index of this from this. So we have the board index, which is the index of this hexagon in the map. And when we index it in this array, it gives us the prototype for that block. And then from there we can get the texture index. So now I just need to return a new vector 3 for each of these. Okay. And then I guess I need to make sure if any of these are -1, then we'll actually just want to return 0. So if board index is less than 0, because the data at that point doesn't matter because it's not used, but if I tried to index -1 into this array, it would throw an error, obviously. Alright, so I think we're looking pretty good. So now I just need this layout to set those variables. And we actually don't have to deal with the prototypes ourselves here, so we just need the board index. And section dot board index, and I guess I'll set my neighbors to -1 to show that we don't deal with that. Okay. So hex position, my hex is just this, but without caring about the side. Oh, but we also, this is just flat actually, because we need to figure out the height. Okay, well since I already calculate that here, I don't really need a separate function. Okay, so I gotta call get surface altitude twice. Column and row. Oh, I should. That won't work because these are not changeable. Do I actually need to know this integer separately? Because I just change it into a hex position anyway. And let's just pass in flat. Okay, and then we'll return new hex position, flat column. Oops, don't need that extra D at the beginning. And whatever layer we just found. Oops, I always misspell that. And then I guess if one doesn't exist, I'll just return -1, -1, -1. Oh, I did this wrong. That should be flat is valid, and then we pass the board. Oh, I see what I did there. Okay, so now that I updated that. Okay, so now I can just update this. What's it not like? Oh, that's a vector 2. And instead of a hex position. Okay, and I'll just pass 0. There we go, that's fixed. All right. So again, we're just finding the first block. Well, we want to find the surface, so it's the first block that has air above it in a certain column, or I guess vertical column, I guess is what you would say. This will be neighbor hex. Okay, so now that I know that, I just need to convert them to their indexes, which is pretty simple. I have this function to take care of that. Oops, but it should be section board index and then section neighbor index A. And then the neighbor index B is unused here, so I can just pass -1. Okay, so I think that's it. Okay, have a few minutes left. Maybe we can try to sneak this in. Okay, so I still need to know the hex position here, but I can actually do it simpler because we know our actual board ID, so I can call hex position from board index. That makes that a little simple. Oh, I just convert it right back. Okay, but we do need both. Oh, I shouldn't have. I just need to get rid of that. Okay, so let's make second case here because we're going to handle the rectangle margins. So create spanning rect margin. Let's move that below all the stuff having to do with the hexagon face. It should be here. And I think I do have some math that I completed for it already. I don't remember if it's totally done. Okay, yeah, I think this was it. So let's pull this out and see what we can salvage. Okay, so this is just setting the type. Yeah, we don't have to do that anymore because it's completed for us. It's the number of points in a big row. I might rename this, but let's wait until all the errors are complete. Yeah, because I think when I was doing this, I thought about it differently because a big row is actually has less points because I think I called this a big row and this a small row because I wasn't thinking about these edges. So that's why I changed it to be odd and even, but yeah, I will rename this later. But this is just given to us by the section dot arrange data 1. And in the small row, which is again actually bigger, we add 1 to it. Yeah, some of this logic will be wrong, but we can see what we can fix. Okay, and the total points we don't have to calculate anymore because that's just given to us right there. Okay, and this is creating the point array. And this total points, and we also need to create the blend array here. Okay, I'll delete that for now. We don't have those anymore. Okay, yeah, we still do that. We still need this. This would be section.side. Okay, and all these offsets are just calculating the different sides that we need to use. So my side A is just, I think I'll make that more explicit. It's just section.side. And then the neighbor's side is +4, and then we loop back around. That's because if we look at this diagram, so if we're on side 0, then the neighbor one is 4, so that's why you add 4. And it works the same for each of them, except when you get to 3, when you add 4, this would be 7, but we actually need it to be 1, so that's why you do the mod 6, which, again, if you've never seen a modulo operator, it just takes the remainder after you divide by 6. So, and we do the same thing for each of these. All right. Running a bit low on time. I'd like to try and update this function. So we'll see if I can complete it. Okay, and my cell, we need to calculate these points now, which I already have here. But we actually need the center position, which I could get right here. And then calculate corner position. So I just pass the center and then the side. So I'll just do something like this. Let's see. Flat center position. And then I'll need to change that to a parenthesis for everything. Let's see, wait. Oh yeah, that's actually went from the neighbor cell. Okay, so I need to change this to my center position. I'll just go ahead and update this so it'll stop complaining about errors. So the hex position, I can just use hex position from board index. Okay, and then I'll need to figure out the same thing for the neighbors. Okay, and this is given to us by the neighbor A's board index. Okay, so what I do here is I loop through for each big row, which I guess is fine, but I can actually... Do I actually need that? Yeah, because that's the lerp between it. But an easier way might be just to go for the total rows. So I might change this logic a little bit. Okay, so number of rows is given to us by section point arrange data 0 and the start point index. Okay, yeah, that just adds after each because it's offset depending on how big the row before you was. We could figure that out. That might be better instead of trying to offset it. Okay, so it would just be int start point index is yeah, so points in a big row. And so for every 2 we multiply this by 1 more, so it would be r divided by 2 plus 1, because at 0 it starts. Or is it? Okay, actually, no, that was right. Yeah, because at 0 it's at 1, and then at 1 it's still 1, but then at 2 we add 1 more. So plus the number of points in a small row, and this is r plus 1 divided by 2. Because at 0 we want this to be 0. Then at 1 it changes to 1, then increases every 2 rows. Okay, and I could change this just to be the row lerp. Get that out of the way. Yeah, this is a little better. Yeah, so at the last row we want this to be 1, which is why I have -1 at the beginning. Okay, so this is all the code that's in common. So if r divide r, we want to see if it's even or odd. So if r mod 2 is 0, that means it's an even number. So we would use this code. If it's an odd number, we would use this code, but I don't know why I did that, because I just... Yeah, a lot of this code is duplicated for no reason, but I didn't see that at the time. Oh yeah, so for every point in the big row, which I think I fixed enough errors that I can try to rename this now. So num points in even row, and then num points in odd row. Okay, so yeah, it's 0 when p is 0, otherwise it's 1 when it's at the last index in there. And I changed this to set point. I don't even have to assign it myself. So start point index plus p. I do need to know the prototype, so I guess I should calculate that here. Okay, so block. Oh, I'm going over, but I want to try to finish this. So my prototype is database. Okay, this is a little like having to index both these arrays each time. I should maybe do a helper function so I don't make that mistake again. Oh, why is it not giving me the section? Oh, and I always forget to change that to board map. Okay, and then the neighbor prototype, it's the same thing except I use this index. Okay, now I can just pass those in here. And yeah, that's a different blends, so I think that's good. So the point lerp is a little different for an odd row because it's not completely smooth. At point 0, it's 0. But then, and then at the last point, it's 1. But then in between there, it's actually p minus 1. Or I guess p minus 1/2 because we have to offset it. So what I could do is clamp it between 0 and 1 and then subtract 1/2 for each, and I think that would still work. Yeah, because if I did that, 0 would be here, but then since I clamp it, it would pop right back. And then the last one would be out here, and then it would be clamped back. So that should be the best way to do it. This might already clamp. I'm not sure. I guess we'll try it and see. Should this be... I think I should subtract 1 because at the last one it should be 1, yeah. Alright, is that right? Actually, I should subtract 2 because at the last one it should be... it needs to be slightly outside this range. Okay, well we'll just see what happens. I think this is right. Okay, and then... Actually, can these set points be shared between them? Well, the problem is we loop in different ways. But I think that all the calls here are the same. Okay. Well, yeah, I've got to go and get some lunch, but I think this is right. We'll test it out tomorrow. Actually, yeah, this is well, it makes a bit more sense than the previous algorithm, so I'm happy about that. I'm glad to see we have some little avatars on the screen too. But yeah, I hope you all have a great day for the rest of your day. And if you're near Houston, Texas, be sure to, I guess, take your umbrellas because, yeah, we're going to get some rain. But I'll be back tomorrow around noon, so if you want to be notified when I go live, feel free to follow me here on Twitch or also my Twitter. I always post there. I also have a YouTube channel if you'd like to catch up on any previous streams, and a Discord channel if you'd like to chat with me throughout the day. I'd love to have you there. And yeah, we'll come back and finish this up. Hopefully start winding down on the terrain system so we can move on. But yeah, this work needed to be done, and I think the sooner the better so that I can start doing more complicated terrain soon. But anyway, I'll leave the stream up for a bit so you can get some avatar coins, and yeah, I'll see you guys tomorrow. Have a great day. Bye-bye.